All right, let me get us started on this one, then I'll pass out the Scantrons. How about that? So I want to use time effectively. So we're in 11.1. We're finishing 11.1. The plan for today, 11.1, 11.4, 11.6. Wow, that's an ambitious plan. We'll see. So 11.1, 11.1 for sure. 11.4, 11.6 maybe. All due on, Thursday? We'll see. 11.6 is in question. It's in strong question. Okay, anyway, so word problems, right? We're finishing up 11.1. It's word problems. It says 1 year there were a total of 82 commercial and non-commercial. Let's just call them C for commercial and N for non-commercial. Total of 82. What do you do with total of 82? Total? You don't subtract, right? How do you total things? Well, you add them. So C plus N is 82, right? So in addition, the number of non-commercial was 2 more. So non-commercial was is the past tense of is, so it's equals, right? Non-commercial was, is, same thing. Non-commercial was 2 more, 2 added to 3 times commercial. See how I just took that second sentence? Non-commercial was equals 2 more than, 2 added to 3 times commercial. N equals 2 plus 3C. Good? That makes sense how I did that? So you solving, we got a lot of sections to do today. So how do you solve when you've got 2 equations, 2 letters like that? You say N, I'm going to plug one into the other. N equals 2 plus 3C. That means wherever I see N, I can replace it with 2 plus 3C. So I can stick it in right there, for example, huh? Right? This N can be replaced by 2 plus 3C because N is 2 plus 3C, right? Okay, so then what do I get? Let's bring this on down. So C plus, and then in the place of N, I'm going to go 2 plus 3C. There's N equals 82. Does that make sense what I did there? In the place of N, I put 2 plus 3C because N is 2 plus 3C. Right there. So now we have, now why is that great? Well, we only have 1 letter now. Now I can solve for C. I've only got 1 letter. C and 3C is 4C. Right, it's 1C and 3C is 4C. Subtract 2. Bring that over here. 4C is 80. Divide by 4. C is 20. C is 20. So we got C. C is 20. Now what do? Just plug in. Anywhere you want. You can plug into any of these equations to get the other letter. Doesn't matter at all. So let me come up here, I guess. And I will plug in. C is 20. Plug into what? To this one maybe. This is N equals 2 plus 3C. 2 plus 3 times 20. What's that? 62. So N is 62. C is 20. All done. Good. Remember that from algebra? You did all that, right? So I'm going to keep moving. They can be a little bit tricky. All right. So there we go. Store sells cashews, $6 a pound. Peanuts, $2.50 a pound. Manager decides to mix. There's the word mix right there. So we're mixing. So how do we do mixture problems from algebra? Do you remember that? Mixture problems from algebra. So I'm going to do the way pretty much everybody does it. The 3 beakers, like chemistry lab or something, or buckets or whatever. So 2 beakers add up to equal, this is the first and the second. They add up to equal this one, which is the mix. So we're mixing 2 things together to produce a final product. So that's going to be the final product mix right there. You put down on the bottom the money or the percentage, depending. Sometimes on mixture problems, they'll say you're mixing 70% acid with 30% acid. What are you going to get? So The bottom goes the money or the percentage. In the top of each bucket, we're going to have two numbers in each bucket, goes the amount. Coming back to you a little bit. Remember this from algebra? So, all right, so let's put the money in the bottom. It's $6 per pound cashews. It's being mixed with $2.50 per pound peanuts. And they want the mix to be $4 a pound. That good so far? So $6 cashews with $2.50 peanuts, and the mix is $4. Whenever you do mixture problems, the final one has got to be between the other two, doesn't it? Because you're doing something more expensive with something cheaper, so the final mix is sort of in between. It's a good double check. It doesn't matter the order on the first two. You could switch it, doesn't matter. But the final one has to be mid-level, has to be between the most expensive and the cheap. The mix is in the middle, right? That's always the case, okay? And now on the top goes how much of that stuff. Like how many pounds of cashews, how many pounds of peanuts, how many pounds in the final mix? Amount, right? The top, it says the top is amount. What is the amount? Well, what does it say? It says 10 pounds of peanuts. Which one of those is peanuts? The 250, right? Peanuts is the 250, right here. Peanuts are 250, and there's 10 pounds of peanuts. So the 10 goes above the 250. It's 10 pounds of the 250 per pound peanuts. Well, then what do you think I put in the blank right here and the blank right there? What goes in those two blanks? X and Y, huh? Those are my two unknowns. So that's where my X and my Y go. And now I'm ready to write some equations. I know whenever you've got two letters, X and Y, you need two equations, don't you? Right? You guys caught that idea, right? With only one letter, you only need one equation. With two letters, you need two equations. So how do I get my two equations? Well, the first equation is just right across the tops. X plus 10 equals Y. X plus 10 equals Y. Why? That's just amount. The amount of stuff coming out of the first bucket plus the amount, the amount of cashews plus the amount of peanuts, pounds of cashews plus pounds of peanuts must be total pounds in the mix. Make sense? That's just total pounds. The second equation is all about the money. Specifically, you multiply top and bottom. Tops and bottoms. Multiply them. What am I talking about? 6 times X, 10 times 250, 4 times Y. And you add them up and they're equal. Why? Well, how much money are all the peanuts worth? 10 pounds of peanuts worth $2.50 per pound. So the peanuts are worth $2.50 for each pound, right? Per pound. And you got 10 pounds of them. So what's the monetary value of all those 10 pounds of peanuts? Well, it's whatever 10 times 250 is, which is actually $25, huh? Does that make sense? And then you do the same thing for the other. So whenever you multiply the amount times the dollar per pound, the number of pounds times the dollars per pound, you get the dollars, right? So over here, that'd be 6 times X, 10 times 250, and 4 times Y. Because whatever the monetary value of all the cashews, what they're all worth, plus the monetary value of all the peanuts, what they're worth, that has to be the total monetary value of the whole mix, doesn't it? That's just the total money equation. So there we go. There's our two equations with two letters. So in other words, we have X, or let me bring it up here. We have X plus 10 equals Y. We have 6X plus 25 is 4Y. Good. Two equations, two letters. So we can solve it. What should we do? There's a lot of ways you can go. Maybe I could solve for X in the top one and plug it into the bottom one. So I'll just move this 10 to the other side. So this one will become X equals what? Y minus 10. Because when that 10 jumps to the other side, it becomes a minus 10. And then you grab that and plug it in for X in the other one. You always plug one equation into the other one, right? So I'll plug it into that one. So what do we get? 6 times x, what's x? Y minus 10 plus 25 is 4y. Like that. So x is y minus 10. Plug in y minus 10 for x right there. Now I have an equation with only y. I can solve for y, distribute. 6y minus 60 plus 25 is 4y. So what am I going to do? I got to solve there. So how about I subtract 6y from both sides? Doesn't matter. You can subtract 4y. It doesn't matter. Just get rid of one of the y's. And then what is negative 60 plus 25? Negative 35? Yeah. And this is minus 2y. I don't know if you can read that. Minus 35 is minus 2y. Kind of running out of room here. Last step. Divide by negative 2. Minus 35 over minus 2 is something. 17.5? Positive. So that's what y is. You could plug in and get x. Then we're done. And you can answer x and y for it on that one. Is that okay? You remember that? A little bit? No? Did you guys do that in algebra? Maybe? Maybe it's a little rusty now. Questions I can answer on that one? We good? I'm going to move on. Okay, so on this one, they're talking about a plane flying with the wind and against the wind. So let's suppose we have a plane that can fly 100 miles an hour on its own. Still air. If there's no wind blowing, 100 miles an hour. The plane, let's say. I'm just making up numbers. I want to get you thinking about what the wind thing does. Let's say the wind is blowing at like 30 miles an hour. Okay? So when the plane goes with the wind, how fast will the plane go? Be able to go? 130, right? You would just add the 30. When you're with the wind, it just adds to your speed, go up to 130. Good so far? It's making sense? And then when you go against the wind, how fast is the plane going to be able to go? 70, because you just subtract the 30. Is this making sense so far? What I'm saying? So if the plane can go 100 miles an hour on its own, with the wind you add the wind speed, right? If it's going with the wind pushes it, adds to its speed. When you're against the wind, you subtract 30 from the original 100, and it slows it down to 7, right? When it's trying to fight against the wind and the wind is blowing against it, slowing it down. Slows it down to 70. So, okay. So, what if somebody told you the following facts? Because this is what they're going to do. What if they said, hey, the plane can go 70 against the wind, 130 with the wind. They didn't tell you how fast the plane could go on its own. That's what they're doing in this question. See? Well, I'll show you how they're doing that in a minute. But just think with me for a minute. What if somebody told you, hey, it can go only 70 against the wind, and it can go 130 with the wind. How fast does it go on its own? They're not giving you the 100. How would you find the 100? What if they just gave you the 70 and the 130 against the wind and with the wind, but they didn't tell you the 100. They didn't tell you how fast it is just on its own.
Subtract 70 from 130 and divide by 2.
Wouldn't that be 30?
No, yeah. And then add the 70.
Yeah, it's the middle, isn't it? Isn't 100 the middle of the 70 and the 130? Right? Because whatever the plane can do on its own, when you add when it's with the wind, subtract when it's against the wind, so it's same distance either side, so the plane's in the middle. So it's really about finding the middle. So somebody gave me the 70 and the 130, and they asked me what the plane is on its own. They're asking me for the middle, aren't they? How do you find the middle of two numbers? We just did a bunch of that, right? The average, huh? The middle is the average. You add them and divide by 2, right? You get 200 over 2. You get 100. That's how you do it, huh? Well, that's exactly what they're doing in this problem. Take a look. They're saying the plane can fly 360 miles, with the wind, I should say. With the wind, so with the wind, let me change colors here so it's clear what I'm doing. So with the wind, the plane can fly 360 miles in 2 hours. See what it says there? With the wind, 360 miles in 2 hours. So what does that mean its average speed is? If I say, hey, that thing can go 360 miles in 2 hours. So how do you figure out its speed? It's miles per hour. Divide, huh? Miles per hour, it's miles divided by hours, huh? Which comes out to be 180. Average speed is 180 miles an hour. Does that make sense so far? With the wind. That's the with the wind speed. So with the wind, the plane averages 180 miles per hour. Because why? Because it did 360 miles in 2 hours. So if you divide those, you get 180 miles per hour. And now, against the wind, then they'll tell us some against the wind facts. What do they say? Against the wind, the plane can fly the same distance, but it takes it 3 hours. Let me get rid of all this. Okay, so let's try that. So against the wind, it can go 360 miles, same trip, but it takes it 3 hours to make the trip against the wind. Divide that, you get 120 miles per hour. That's the speed against the wind, average speed. So, and then they're asking us, find the wind speed and the air speed of the plane, meaning, the plane alone without the wind. So let's find the plane speed first off. So how are we going to find, if the plane goes 180 with the wind and 120 against the wind, what's the plane do on its own when there's no wind? It's the middle.
Take the average of the hours?
Yeah. So the average is 180 plus 120 over 2, huh? You got to take the middle of those two speeds. Because the wind speeds it up when you're with it, slows you down when you're against it. The middle of those is just the plane alone. What's that, 300 over 2? 150? So 150, that's the plane's speed on its own. No help or hindrance from the wind. The plane can go 150 miles per hour. Okay, great. The plane can go 150. They also want me to know how fast the wind is blowing. How do you figure out how fast the wind is blowing?
You just plug in the 150.
Can you just tell me the answer? Can you just see it? Is it hard to see? So the plane can do 150. When the wind helps it, it does 180. How fast is the wind blowing? 30. Done. Right? Wind's 30. In fact, we got lucky right there. We had it. Does that make sense what I did there? Is that confusing, right? We figured out the plane's 150, right? Because we took the middle. We said 180 with the wind, 120 against the wind. Then we took the middle of those two. We averaged them. Got 150. That's the plane alone. That's plane alone. No wind. No wind, plane alone. Does that make sense? This is no wind, plane alone. Because it's the middle of the wind helping and hurting, right? And then once you got the plane alone, you just go, well, 150 plane alone, 180 when the wind blows, 30. The wind's doing 30. The wind's helping by 30. All right, I'll move on. I'm glad to help you. If this is, I know. All right, restaurant manager wants to purchase 200 sets of dishes. One design costs 15%, the other's 45%. Total budget $4,800. How many of each? So it's a traditional money problem. So you're buying two kinds of things. So you're buying you're buying a bunch of sets for a restaurant, a bunch of sets of dishes. The cheap ones are $15 per set. The expensive ones are 45%. You got to get 200 sets total. That's what the restaurant needs. And you can afford to spend $4,800 on the sets altogether. So how many cheap ones and how many expensive ones should you buy to make 200 total sets that cost $4,800 total? All right, so on money, this is typical money problem. So on a typical money problem, at least the way I teach it, I think most people, the first equation has no money at all, and the second equation is all about money. It's basically separating out the money from the no money. So the first equation is going to have no money. I'm going to call it, I don't know what, let's say cheap sets and expensive sets. How about C and E? You can use X and Y if you want to, but it's kind of nice to have meaningful letters. That way you know what they are right away. So C for the cheap sets, E for the expensive sets. So the first equation is no money at all. So I'm gonna go C plus E is 200. See, that has nothing to do with money. There's no money involved in that first equation. That's just treating them like objects, having nothing to do with their monetary value. The number of cheap sets plus the number of expensive sets must be 200 total sets. We don't care what they cost. We're just saying total number of sets must be 200. That's a no money equation. Is that good? And then the second one, you bring the money into all three. All three are going to have money now. So how much are all the cheap sets? If C is the number of cheap sets, like maybe it's 15 or whatever, C is the number of cheap sets we purchase, what's going to be the total cost of all those cheap sets? Well, it's 15 times C, because each cheap set is 15. So say C is 20, then whatever 15 times 20 is would be the monetary cost of all the cheap sets. Is that making sense? However many cheap sets times $15 per cheap set, plus however many expensive sets, E stands for how many expensive sets, times $45 per expensive set, must be the total money spent, $4,800. See how it's money, money, money? Money all the way. And the other one has no money anywhere. Like that. That good on that? 2 equations, 2 letters. Off we go. Common mistake, some people go times 200 here. It's not $4,800 200 times, is it? That's not right. It's not like mixture where we multiply. It's just 4,800. All right, so how do you solve this? You guys could do it, right? Maybe I'll do 1 or 2 steps. So what would you do to solve these 2 equations, 2 letters?
Try to get
Yeah, get C alone maybe. Yeah, so just jump this over like we did last time, right? Same kind of thing, huh? That'd be a good idea. So then we get C equals, what is it? 200 minus E, and grab that and plug it into, you always plug into the other equation, huh? Plug in 200 minus E in for C. So we get what? We get 15. 200 minus E. Plus 45E is 4,800. Is that good? To there? That makes sense? And then you just distribute. And can I just go dot, dot, dot? You just do all the rest and solve for E and then plug back in for C. Questions I can answer on that one? Do you remember all that from your glorious algebra days? Sort of?